Next concept is based on the Rook polynomials, in which you have a Rook polynomial formula, as well as we are going to learn the expansion formula. So two formulas we are going to see, the Rook polynomial as well as the expansion formula under the principles of counting. So let us go to the definition of Rook polynomials. Consider a board that is nothing but a chessboard. Okay, consider a board. Now if this is a chessboard, we're going to consider a chessboard or a part of a chessboard. Consider a chessboard or a part of a chessboard. Let n be the number of squares present in the board. Now n is nothing but whatever the squares present in the board, as well as, now for example, in the chessboard you might keep the pawns. Okay, for example, you might keep in this location, in this location, and in this location. So n will be nothing but where that exactly the pawns are placed. If this doesn't contain anything, then n will be not considering this, so n will be just the value 3. Okay, consider a board that resembles a full chessboard or a part of a chessboard. Let n be the number of squares present in the board. Whatever that squares is being used, right, those we are going to tell it as n. Pawns are placed in the squares of the board such that not more than one pawn occupies a squares. So whatever I told, right, regarding the pawns, it will be placed in a chessboard where not more than one occupies that particular square. So according to the principle of the pigeonhole, not more than n pawns can be used. That means only one pawn can be using one particular square. Okay, so two pawns placed on a board having two or more squares, for example, are said to capture each other if they are in the same row or in the same column of the board. Okay, so based on this we have the polynomial formula. So this is regarding how the pawns are being placed. So just remember that each pawn should occupy only one square. Okay, now more than two, if it occupies, then it is not a, we cannot consider it. So one square, one pawn can occupy. Anyhow, any location you can occupy. So whatever the pawns is occupied in this. Now for example, if this is a set of 4, right, 1 2 3, I mean 4 squares, but only 3 pawns occupied, then n value will be 3. And this is the Rook polynomial formula, which is a very important formula we'll be using over here. Okay, this is the first formula, Rook polynomial. Over here n now for this will be 3, whereas R2 is nothing but for two pair items. Okay, for two pair items. Now what they have defined is, that is, we call R2 or Rn, whatever that, RK, it is nothing but number of ways in which, this is nothing but the number of ways in which k pawns can be placed. K pawns can be placed on a board such that no two pawns capture each other. Okay, that is, no two pawns are in the same row. Meaning is what, no two pawns. Now for example, this is just for this R2 is actually 0. N is nothing but one single item you're going to find, 1 2 3, like this you're going to go. R2 is a pair of two items. Now for example, if I draw something like this, 1 2, this is a square. Okay, and here somewhere 1, let me assume that pair is 1 and 3 2 3 4 5 7 8, something like this. Okay, 1 2 3 4 5 6 7, I'll put 6 7 so that no confusion. So how many n value would be? 1 2 3 4 5 6 7, I mean 3 4 5 6 7, n value is 7. Okay, single items. R2 is nothing but number of ways in which pawns can be placed on a board such that no two pawns capture each other. Meaning is, no two pawns are in the same row. No two pawns are in same row or in same column. Are in same row or in same column or in same column. Okay, meaning is, now when you find R2, right, you should select a pair such a way that they are not in same row and same column. So you cannot make a pair. R2 is a pair of two items. So 1 2 you cannot, 1 2 you cannot do, 1 3 you cannot do, 1 2 you cannot do, 1 3 you cannot do, 1 4 you cannot do, 1 6 you cannot do. So 1 5 is possible, 1 5 is possible, that is it's not in a same row or it's not in a same column. 1 7 is possible, 1 7 is possible, but this and this is not possible, 1 7. So similarly for this board, right, R2 pairs of those two items will be 1 5 1 7. For 2, right, you cannot combine with, for 2 you cannot combine with 3 as well as 1, 3 as well as 1. So 2 can be combined with 4, 2 can be combined with 6, since it does not have in same row and same column. So it will be 2 4 2 6, and 2 can be combined with 5 and 2 can be combined with 7, 2 5 2 7. Whereas for 3 you cannot combine with this column and this, so it is 3 4 3 6, 3 4 3 6. Whereas for 4 you 4 is already 2 4 is done. 4 above you cannot do, okay, already you are completed. So this row you cannot and this row you cannot. Only 4 7 is possible. Above it's already combined, right, 2 4, no need to consider that. So it is 4 7. And for 5 you can combine with 5 6. So you will get 1 2 3 4 5 6 7 8 9 10. So this R2 value will be 10. Similarly R3 is pair of 3 items. Again, it should not appear in the same column and same row. So you'll understand better while solving the problem. So just remember n, whatever is placed in this, that is the count, single item. R2 is your finding pair of items, but condition is it should not appear in the same row or same column. So this is the root polynomial we are going to do. So let us go directly to the example. Example 1. Consider the board shown in the figure below, which contains 4 squares, that is 1 2 3 4 is already filled. So from this your formula for the root polynomial you just write. If you consider this as the chessboard, right, so you can put it as c comma x, r of root polynomial of c comma x. Now this c is nothing but we considered it as a root polynomial for the given board. Okay, if the board is given the name c, for example, if the board is given the name c, then r of c of x would be, formula would be 1 plus r1 of x plus r2 of x square plus so on till rn x to the power n. So this is the root polynomial formula, previous formula itself, but instead of R1 same formula, but I gave a board name as c comma x. Okay, now consider the board shown in the figure. Now what we are supposed to find, root polynomial. So r1 is nothing but n itself, r1 is nothing but n itself. So you can just write 1 plus r1 is nothing but n. You remember, right, number of squares in the board. So from this you should find, in this board you should find what is the value of r1, what is the value of r2, and finally substitute back to this particular root polynomial. So from this board you can write over here, from this board r1 is equal to nothing but n, right? So 1 2 3 4, all 4 are filled, so r1 is 4. So we got to know what is r1. Next we have to find the value of r2. Okay, we got to the value of r2. To find the value of r2, you should find the number of ways which can, on the two of them can be captured. Okay, the number of ways in which two rooks can be placed. Okay, the number of ways in which two rooks can be captured that is, find the pair of two. I mean R2, right? You have to find the pair of two where same column and same row doesn't repeat. So you try with 1. So if you try for 1, finding the finding a partner for 1, then this cannot be considered, this cannot be considered. As I told, R2 is like where same row and same column cannot be considered. So you can combine, captured is 1 comma 4. One possibility is 1 comma 4. This can be combined because this 4 doesn't come in same row and same column of 1. Next, when you come to 2, right, 2 cannot be combined with 4. 1 previous you cannot, then 2 can be combined with 3. So the value of R2 will be 2 now. R2 will be 2. Okay, so the rooks. Next, R3. Can we have R3? No, because there is no next term. So R3 is 0. R3 is 0. So accordingly, the rook polynomial will be, the rook polynomial will be R of c comma x 1 plus r1 of x plus r2 of x square. That's it, because r3 is not there. So 1 plus r1 value is 4x plus r2 value is 2x. So root polynomial is 1 plus 4x plus 2x square. 1 plus 4x plus 2x square. Okay, so this is the solution for the example 1. So I'll just repeat. This is the formula for the root polynomial. R1 is nothing but the value of n. N is a single item. So how many are placed in the chessboard? 4 items directly. R2 is a pair you're going to find. R2 means 2 items. Okay, but those 2 items should, now for example for 1 you're going to find a partner who should not belong to the same row and same column. So for 1 the pair is 4. Okay, similarly for 2 the pair is 3, whereas for 3 you cannot consider backward, that is 3 1 and 3 4. This 3 2 you cannot combine because already 2 3 is done. Below there, if you have below any item you're going to check. Even for 4, if a below item is there you're going to check somewhere over here. Okay, R3 we don't have 3 items set itself here, just it is a 2 into 2 board. So you got the value of R2 is 2. So next, example 2. Consider the board shown in figure below, which contains 5 squares marked 1 to 5. So here you have 1 2 3 4 5. Okay, so same for this also you have to find the root polynomial. From this board you came to know that R1 is what? R1 is 5. 1 2 3 4 5. This is not marked, so R1 is 5. R2 we have to find. For R2 you have to find the pairs, right? So we know that 2 non-capturing rows can be placed on the board in the following positions. Okay, just write 2 non-capturing rooks can be placed on the board in the following position. On the board in the following positions. In the following positions. Okay, so for this following positions you should find. Now from 1 you start. It cannot be combined with this and cannot be combined with this, so it is 1 comma 5. Okay, so 1 cannot be combined with 4, 1 cannot be combined with 2 3, so the partner is 1 comma 5. Similarly 1 is done. Now go with 2 cannot be combined with this and this, same column and same row. So 2 can be combined with 4 and 2 can be combined with 5. So 2 comma 4 and 2 comma 5. Got it? 2 comma 4 and 2 comma 5. Now 2 is done. Go to 3. 3 cannot be combined with this and this. 3 can be combined only with 4. So 3 comma 4. I hope you remember the definition. When you find a 2 pair, it should not consist a pair of same row and same column. So this can be combined. 3 comma 4. Next you will come to 4. When you come to 4, you cannot combine with this and cannot combine with this, but you cannot combine with this also because it is already done. 3 4. Below, if it is somewhere else there, you can do it. Even for the 5. So the pair you have R2 value over here, you will get it as just 4. What about R3? R3 means 3 pairs you have to do, but that is not possible in this. Okay, next example I'll show you regarding the R3 pair, because for R3, right, there should be one more row attached over here. So it's not possible for R3. So R3 is 0. So based on this, the root polynomial will be the root polynomial for the board would be thus. Therefore the root polynomial is 1 plus R1 value was 5, right? 5x plus r2x square, right? The formula, if you remember, r2x square r1x, so r2x square, that is 4x square. So this is the root polynomial for the example 2. Next, example 3, consider the board shown in the figure below which contains 6 squares. Okay, now this is how you're going to find 2 non-capturing, and then again you have to find 3 non-capturing. Okay, 2 non-capturing rooks that can be placed and 3 non-capturing. So this is the board. From this board you clearly came to know that R1 formula, you know, R of C of x is equal to 1 plus R1 of x plus R2 of x square plus R3 of x cube, so on, Rn xn. This is a formula. From this board you came to know that 1 2 3 4 5 6, R1 value is 6. Okay, R2 you should write the same statements again. 2 non-capturing rooks can be placed on the board. Okay, R2 is 2 non-capturing board, 2 non-capturing rooks can be placed on the board in the following positions. On the board in the following positions. In the following positions. So it would be, so R2 is nothing but pair of two things, right? So one, you have to do it with, you have to find the pairs, 2 pairs. So this cannot be possible, this is not possible. So 1 3 is possible, 1 5 is possible, 1 3 is possible, 1 5 is possible, 1 6 is possible, but this and this is not possible. Same row, same column. So 1 can be combined with 1 3, 1 5 and 1 6. That is 2 pair you have found. Okay, and now 1 is done. Next go with 2. For this 2, there is not, we cannot combine with this, but it can be combined with same row same column, not possible. So it can be combined with 2 3, 2 4 and 2 6. Okay, similarly 1 2 is done. Now with 3 cannot be done with this and this. Below, whatever, up already we did the combination, right? See here, 3 2 and 3 1 is done. So below you check whatever is the possible. So it can be 3 4 and 3 5, 3 4 and 3 5. And for this there is no possible. For 4 5 6 nothing, we cannot do anything because it does not have 4. If you check with 4, this and this is not done. I'm just telling 4, if this and this is not possible, whereas 4 2 4 3, but 2 4 2 3 2 4 and 3 4 is already done. So for this row, right, you don't have to find 2 pairs. So this is regarding R2. So R2 you got it as 8. R2 you got such pairs, you got it as 8. Okay, R2 you got it as 8. R3 we can find because it is a 3 now, 3 cross 3 board. R3 is again, I'll not write, it is a 3 non-capturing. Okay, 3, you write the statement same, 3 non-capturing rooks that can be placed on the board in the following position. I'm just writing over here R3. So for R3 you have to find the combination of again 3, but again it should not be in the same 3 pairs. Again it should not be in the same same row and same column. So it can be placed only in the following 2 positions. See here, for 1 you cannot go with this and you cannot go with this, same row and same column, but you should find a pair of 3 items. So you can find it in this way. 1 can be paired with 3 and it should be paired with, again with, not with the same row and same column of 1. So 1 3 5 is possible and 1 3 6 is possible. So 3 item pair, 1 3 5 and 1 3 6, 1 3 5 and 1 3 6, 1 3 5, sorry, 1 3 6, no, again sorry, you cannot find 1 3, wait, I'll just repeat. It should be like 1 here. For this it should not be same row same column, got it? So 1 can be combined with 3. If you combine with 3, then again this also 3 should not have same column and same row. So that left out is what? This is done, this is done, this is done. So 1 3 5, 1 3 5. Why 1 3 6 is not possible? I did a mistake. 1 3, 6 and 3 are in same column, so it's not possible. So one part of pair is this. I hope it's clear. Again, I'll repeat. If you want, you just circle for 1. When you circle for 1, this column and this row is not there. You have to find now 3 partners, I mean not 2 pairs, 3 together at a time. So I combined 1 3. Okay, 1 3 I combined, 1 3 1 3 I got a pair. Now for this 3 I should get a pair which is not again in the same row and same column of 3. Not this, not this. So left out is this. So 1 3 5 I got it. It's not possible with 1 3 6 because it is in the same column. After that, go for the 2. Now 1 is done, go with 2. For 2 this is not possible, I mean this is not possible and this is not possible. Okay, so 2 can be combined with 3, agree, 2 can be combined with 3, but again with this 3, right, I shouldn't have same row, I mean same column and same. So 3 can be combined with 4, so it is 2 3 4. I'll repeat again. Next we went to 2. In that 2 I cannot get with this and I cannot get with this. Okay, now this 2 can be combined with this when I want to do the 2 pair. I did this 3. Now when this 3 came, again I cannot combine with this, I cannot combine with this. So 2 3 is a pair. For that, again one more pair I can find is only 4. So it is 2 3 4. So the value of R3 is 2. So the root polynomial will be R of C of x would be 1 plus R1 of x plus R2 of x plus R2 of x square, R3 of x cube. So it would be 1 plus R1 value is 6 and x with this, R2 value is 8 x square and R3 value is 2, that would be 2x cube. So this is the root polynomial for this particular equation. I hope it's clear with this example 3. Next we have example 4. Consider the board shown in the figure below which contains squares 1 to 8. So again I'll write R1. So the formula is same. R of C of x is equal to 1 plus R1 of x plus R2 of x square plus R3 of x cube. So it is 3 cross 3, max it will go for R3 of x cube. Okay, so here what is the value of R1? It is given already. R1 8 occupies, so R1 is 8. R2, write down the statement. I'm just writing the pairs over here. Okay, write down the same statements what we had written for 2 non-capturing in the board. That statement you're supposed to write. For R2 the pairs I'll just write. So for 1 I cannot consider with this, so it is 1 comma 5. 2 3 will not come, 4 6 will not come, so it is 1 comma 5, 1 comma 7 and 1 comma 8. Okay, for R2. Then 1 is done, right? Now 1 is done. Next you will go with 2. For 2 again this and this will not be combined, so it will be 2 4 2 5 2 6 2 8, 2 4 2 5 2 6 and 2 8, 2 4 2 5 2 6 2 8. For 3 again this and this will not be combined, whereas this will be there. For 3 again this and this will not be there, so it would be 3 4 3 6 3 7. Same row same column will not be there. Now for 4 this and this will not be there, so it will be 4 7 4 8, 4 7 4 8, 4 7 4 8, 4 7 and 4 8. Okay, next you'll go for the 5. For 5 this and this will not be there, so it would be 5 6 and 5 7. So this is the 2 pairs. Now try to find count the values of R2. So it would be 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So the R2 value will be 14. R2 value will be 14. Now try to find the R3. Again that is a 3 non-capturing, so just write down the statement what I have written in the previous problem. So R3 would be, pair of R3 would be, so I told, right, 3 combinations, right? So if I take 1, then this and this will be excluded. For the pair matching for 1 is nothing but 5. But if you consider 5 again, then this and this is not considered. So it would be 1 5 7. 1 5 7. Why? Because 7 does not appear in the same row and same column of 1, and 7 doesn't appear in the same row and same column of 5. So 1, 5, 7 is the pair. Okay, so that is for the only one pair I got when it considered for 1. Next we'll come to 2. When I come to 2, it would be, this will not be there and this will not, this entire straight will not be there. Okay, this will not be there, but this 2 should be paired, right? So 2 can be paired either with we'll go with the 4. 2 can be paired with 4 and 2 can be paired with 5 also. Okay, 2 can be paired with 4 and 2 can be paired with 5 also. So if I pair it with 4, right, if I pair it with 4, 2, 4, one combination, then this will not be there, this will not be there. So possibilities 2, 4, 8. Possibilities just 2, 4, 8. See, in the 2 itself I got 7 got cancelled, this got cancelled. When it came, I paired with 4, right? I paired with 4, then this got cancelled and this got cancelled. So left is only 2, 4, 8. You can just check here. When I circled 2, this and this I cancelled. Next I paired with 4, that this and this got cancelled. So 6 and 7 already lost. Left was 8. Okay, left was 8. So 2, 4, 8. Next again possibilities. If I combine the combination, that is again for 2 itself, this and this is done, cancelled, and I did already with 2, 4. Now 2, 5 if I do, 2, 5, that means this and this if I do connection, then this will not be there, this will not be there. Okay, so left out is what? 6. So 2 is paired with 6. 2, 5, 6. Next if you go for 3, now 1, 2 is done, 1, 2 is done, 1, 2 is done. Go for 3. When you go for 3, this is not there, this is not there. So 3 can be paired only with 4, only 4. This and this is lost, only with 4. So 3, 4 means, again this is not there, this is not there. So 3, 4, 7 is the pair. 3, 4, 7 is the pair. So in 3 cross 3, right, 3 cross 3 board, only if you find first row for 3 items it's enough. For this, no use at all, because you will get again, you don't have third item to be found. Okay, only for the first row if you find such 3 pairs it's enough. So R3 you got the value of 4. R3 you got the value of 4. So this is regarding the Rook polynomial finding R3. Now Rook polynomial will be, therefore the Rook polynomial is R of c comma x 1 plus R1 value we got it as 8x, R2 value we got it as 14x squared, and R3 value we got it as, R3 1, 2, 3, 4, right, 4x cubed. So this is the Rook polynomial. This is the Rook polynomial of this particular board. Next, in this concept itself, we have expansion formula. Now what is this expansion formula is, we are dividing the entire chessboard, right, entire chessboard into 2 sections. Okay, now for example, I'll just put like this, something like this. Wait 1 second. So this chessboard I'm going to divide exactly into 2 sections. Okay, this chessboard I'm going. So the Rook polynomials have many interesting properties. Below we indicate the 2 of this. In a given board C, if this is a given board C, suppose we choose a particular square. Now for example, I choose this particular square and I marked it as star. Okay, let D be the board obtained from C by deleting the row and column containing the square. That means, now for example, if I'm dividing, expansion formula is I'm dividing this entire chessboard into 2. Okay, one is D and other one is E. Now for example, if this is the board, and I put star over here, then I'm going to one property I'm going to do is, one board I'm going to get, that is the D board, where it is obtained from C by deleting the row and the column containing the square. That means I'm deleting this and this. That means only these 4 outer boxes are considered. For example, if this is the board, same board I'm going to draw. If this is the board, I'll draw over here. Again, same board, but but this and this will not be considered. Remember this shaded part, right? Only 1, 2, 3, 4 will be considered. For that you have to again apply root polynomial itself, same root polynomial concept itself, but this is D. Remember that this is D. Whereas E is what, you know, excluding this. Now E is nothing but excluding this star. Same 1, 2, 3, 1, 2, 3. Okay, now star was center, right? This you have to shade. Rest every part is considered. I hope you got it. The root polynomial, this is the main board. You can mark this star anywhere, okay, not only in the middle. If you mark anywhere that star, that column and row will not be considered. This row as well as this column is not considered while calculating the root polynomial. That is D. And E is nothing but only that star is being excluded and rest all is being considered. So that's what here you see. Let D be the board obtained from C by deleting the row and the column containing the square star. Let E be the board obtained from C deleting only the square star, only the star. Then the root polynomial RC of x. Again, root polynomial is nothing but x into root polynomial of D of x. X into root polynomial of D of x plus R into E of x. So that formula for the D of x is again our same formula, this formula itself. Okay, instead of C it is D of x, instead of C it is E of x. That same formula, but it's been divided into two boards. This is known as the expansion formula for R of C of x. Example 5 is based on find the root polynomial for 2 cross 2 board by using the expansion formula. So by recalling the expansion formula, we know that expansion formula is nothing but R is equal to R of C of x is equal to x into R of D of x plus R into plus R of E of x. Now basically this formula is same of our root polynomial formula itself, but expansion formula is equal to the D of x plus R of E of x. So here he has told find the root polynomial for 2 cross 2 board by using the expansion formula. So this is the 2 cross 2 board. Now what I've done is by using expansion formula means we are supposed to mark one star. So when I mark the star, let me mark star to 1. When I mark star to 1, then this as well as this elimination, the row as well as the column elimination, left out is with 4 is only D. Okay, and just excluding 1 is E. Rest all the contents are there, that is 2, 3, 4. So if you recall the definition over here, as I told, let D be the board obtained from C by deleting the row and the column containing the square, and let E be the board from deleting only the square star. So over here I hope it's clear. When I put star for this, then this row as well as this column deletion, left out only with this is D, and when I put just remove this one and left out other items, if I write it is E. Now for this let us tell that the solution will let us write, right? Let us mark the square numbered 1 as star. Let us mark the square numbered 1 as star. Square numbered 1 as star. Okay, as star. Then the board D and E appears this way. Then the board D and E appears as below, like this. Okay, appears as below. Now for this we have to do use the expansion formula. That expansion formula is R of C of x, x into R of D of x, x plus R into E of x. Now this D of x, again we are going to find R of D of x. It has only one element, so it is just 1 plus x. If you know, it's R1 is just one element is present in this. So the R of D of x would be, the board D contains only one square, so it would be R of D of x would be 1 plus x. For the board E, this is for the board D, okay, for the board D, and this is for the board E. For the board E, R of E of x you have to calculate. R of E of x you have to calculate. So before you calculate R of E of x, for the board E you should find what is R1. For the board E, R1 is 3. If you remember, R1 is 3, single item. So 1, 2, 3. R2 would be if you take from 2, then this and this is deleted, then it can be combined only with 2, 3. R2 can be only 1, R2 can be only 1, and R3 there is no item, so it is 0. So for the R2 one, the corresponding pair is, it is 2, 3. Therefore, I'll write over here. Therefore, R of E of x would be nothing but 1 plus 3 of 3x plus 1x square. 1 is R2 value, R2 1x square. So this is R of E of x, R of D of x we got. Finally, therefore, the expansion formula. Now the expansion formula yields. Now the expansion formula yields R of C of x is equal to x into R of D of x, that is nothing but 1 plus x. You write this formula over here, okay, then you write this x into 1 plus x plus R of this E of x, so that is 1 plus 3x plus x square. So this would result into x plus x square plus 1 plus 3x plus x square. So this would give me 2x square plus 4x plus 1. 2x square plus 4x plus 1. So this is the required, by using the expansion formula, this is the required polynomial what we got. So if you check this result with the one what we got, example 1, then again the answer is same. If you just check with the example 1, see here, for this itself we solved using Rook polynomial, but by expansion formula also you got 1 plus 4x plus 2x square. Similarly, even here we got it as 1 plus 4x plus 2x square. So this is regarding the example 5. So similarly, for the example 6, find the Rook polynomial for 3 cross 3 board by using the expansion formula. So 3 cross 3 board, for that we are going to find using the expansion formula. So let us mark the square which is at the center of the board. Now for example, if we mark at this particular board, so let me write 3 cross 3 is this board, okay. So let us mark the square which is at the center of the board as star, which is at the center of the board as star, okay, which is at the center of the board as star. Then the boards D and E appears. When we mark this, what is the D and E appears? So when you mark this, left out, this should not be written, we are not going to write this part. So the D and E appears, then the board D and E appears as shown below. Okay, not this, okay, D and E, I'll draw it in a new page. So then the D and E appears as shown below. So if you put this, when you do it D, this box will not be considered, this will not be considered, this will not be considered, rest all the boxes will be considered. So we'll shade that particular box. So that is okay. So when you put over here D boxes where this as well as this will not be considered. D, that is only 1 2 3 4, this is considered 1 2 3 4, whereas E box this will not be considered, rest all will be considered. 1 2 3 4 5 6 7 8. So this will not be considered, rest all will be considered. So this is regarding 1 2 3 4 5 6 8, okay, 6 7 8, this is considered. Now for this we have to find R of D of x as well as R of E of x. So let us find for the first box R of D of x. Let us find R of D of x. So for finding R of D of x for the board D, for the board D, R of D of x we have to find. R1 is equal to 4 if you check, because this will not be considered, okay? This will not be considered because you marked star at the center, so that column will not be considered. So it will be considered only 1, 2, 3, 4. So R1 is 4. R2 if you see, when you consider 1, this and this is not there. So the pair will be for R2, the pair is 1 comma 4, and when it is 2, for this when it is 2, then this and this will not, 2, 3, it is 2, 3. So R2 is 2, okay, whereas R3 is 0. So for this equation, R of D of x is nothing but our old Rook polynomial formula itself, 1 plus R1 of x, that is 4x, plus R2 of x square, that is 2x square. Okay, 1 plus 4x plus 2x square. For the board E, R1 is equal to 8. If you check here, R1 is equal to 8. R2 will be, what are the pairs you try to find? R2 will be, if it is 1, it is this and this, 1, 5, 1, 7, 1, 8. The corresponding pairs. For R2, the corresponding pairs will be 1, 5, 1, 7, 1, 8. Okay, this and this is not considered. 1, 5, 1, 7, 1, 8. For when you come to 2, this is not there and this is not there. So the possible pairs are 2, 4, 2, 5, 2, 6, 2, 8. 2, 4, 2, 5, 2, 6, 2, 8. Similarly, when you come to 3, this will be not considered, this will be not considered, but 3, 4, 3, 6, 3, 7 will be considered. 3, 4, 3, 6, 3, 7 will be considered. Now 1, 2, 3 is done. Come to 4. When you come to 4, this row and this is however not considered, only with this. So 4, 7, 4, 8. 4, 7, 4, 8. When you come to 5, this is not considered, this is not considered. So 5, 6, 5, 7. So this problem is already solved in example 4. Same, this table itself is solved in example 4. So better explanation you can see here, example 4. So this problem is already been explained. Okay, example 4. So 5, 8. So this is for the R2. So how many pairs are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So therefore R2 is equal to 14. R2 is equal to 14. Okay, now similarly find R3. R3 would be, if I just try to combine with this now, in case if I want to erase it, let me erase this section. Okay, I'll do again in same E box, I'll do it again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. For R3 it is 1. When I do 1, when I circle 1, this and this will not be there. So 1 can be combined with 5, 7, but for those 7, 8 I cannot do it. I'll tell 1, 5, and when it comes to 5 again, this and this is not considered. So it is for R3, the 3 pairs are 1, 5, 7. I got it, 1, 5, 7. Okay, 1, 5, 7. Now we'll go to 2. When you go to 2, this is not there, this is not there. So you can either get it with 2, 4 or 2, 5. Okay, when you do with 2, 4, then this is not there, this is not there. Okay, so it will be 2, 4, 7. Either you'll get it as 2, 4, 7, or you'll get it as, either you'll get it as 2, 4, 7, or you'll get it as 2, 4, 7. Well, no, you cannot combine with 2, 4, 7. Why will not combine? Because 2 and 7 lies in the same row. Sorry, you cannot combine with, wait 1 minute, I'll make it a bigger one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we did the combination of 1. When I did 1, this and this was not combined, so I combined with 5. When I combined with 5, this again is not considered, this is not considered, so left out is only 7. 1, 5, 7, 1, 5, 7. After that, after 1, 5, 7, next 157. Next I have 1 is done. Next go to the 2. Next when you go to 2, what you're going to do is you're combining 2 with not this row as well as this row. So you can do the combination with 2 5. You can do the combination with 2 5. You can do the combination with 2 5. When you do combination with 2 5, this is done and this is not there. So 2 5 either 6, but that 6 appears again either 2 5 6, or when you do 2 5 again this is not there, this is not there. So it will be either 2 5 6 or 2 5 6. Okay, one pair is 2 5 6. That is possible. One more is 2 can be combined with 4. When you do 4, this and this is not there. So 2 4 8. 2 4 8, and then again 2 is done. Then again you will go to the pair 3. When you go to the pair 3, this is not there and this is not there. So 3 can be combined with 4. When you combine with 4 again, this is not there, this is not there. So left out is 3 4 7. 3 4 7. So therefore R3 value would be 4. So based on this the equation would be for E board, R of E of X, the board would be 1 plus R1 of X is, R1 is 8x and R2 is 14x x square and R3 is 4x cube. Okay, so this is R of E of X and this is R of D of X. Now your expansion formula. So if you remember the expansion formula, that is R of E of X is nothing but C of X is nothing but X into R of D of X plus R of E of X. So it would be X into D of X. If you remember, it is 1 plus 4x plus 2x square and plus R into D of E of X. E of X would be 1 plus 8x plus 14x square plus 4x cube. Okay, 1 plus 8x plus 14x square plus 4x cube. Now you just multiply this, so it would be x plus 4x square plus 2x cube plus 1 plus 8x plus 14x square plus 4x cube. So this would result in, put all one to go in order, 1 plus 8x plus x 9x plus x square you add, so it would be plus 18x square, that is just 4x square 14, lastly plus 6x cube. So this is the result for this particular problem using the expansion formula. So this is regarding the example. So we 2 examples based on the expansion formula, rest 4 examples are based on the general Rook polynomial. So expansion formula is also one type of other way which you can solve the Rook polynomials. So thank you.